Thanks, Brian, and good morning, everyone. So my name is Chris Lau, Systems Engineer at Red 8. It's my responsibility to keep an eye on the chat today and keep any technical questions answered or make sure that Todd gets a hold of them. So if you are like me, you've probably been wondering, how on earth can I keep up with unstructured data? Well, fortunately, today we have someone who's able to show us just how to do that. Todd Frederking joins us from Arrow Electronics, where he's been a solution architect for a number of years. Prior to that, he actually worked for DellEMC, so same background as me. So he's got a long history in the industry, and I'm very excited to hear him speak today about unstructured data. As I mentioned, I'll be watching, keeping a close eye on the chat. And with that, I'll hand it over to you, Todd.
Thanks, man. If I can get my screen share set up correctly here.
I'll let you know when I can see it.
There we go.
Yep, I see it.
Okay, cool. Okay, so thanks everybody for hopping on today. What we're going to talk about today is sort of two things, sort of how we got here, and then there were some major announcements in the Isilon family from Dell Technologies 2 days ago on Tuesday. There are some new hardware, and there's also some software updates, and it's all falling under what we're now calling PowerScale. PowerScale and Isilon are one and the same niche. They're really just kind of two different groups of nodes within the Isilon family. Again, this happened 2 days ago. I've been calling it Isilon for quite some time. So you're going to hear me probably interchangeably use the two terms PowerScale and Isilon, and just as a point of clarification, the two apply to each other. And as we kind of get through the content today, you'll sort of understand that OneFS, Isilon, PowerScale, whatever we're calling it, OneFS is the software that sits underneath it all and makes it all hum, and that's really kind of what we're talking about. So Isilon and or PowerScale really sets the standard for file-based NAS storage, and it does so by being different. And while the management of OneFS is designed to be simple, there's some underlying architectural differences that for traditional storage folks sometimes takes a minute to get your head around. Again, OneFS, the underlying OS that really makes Isilon hum as of 2 days ago, is now at 9.0. So it's mature, and it's an evolved solution. So if you're new to Isilon and or PowerScale, expect to see something different. And if you're not new to Isilon, then as of 2 days ago, we've got some new information to share, and we're happy that you're here looking to know more about that. So here's a quick agenda of what we're going to talk about. We're going to do an overview of Isilon in general. We'll look at the Gen 6 hardware that is still extremely current and valid. What we saw on Tuesday is just additive to that. So it's important to sort of understand what that architecture looks like. We'll talk briefly about data protection, and then get into multi-protocol access, and then we're going to talk about some software features that allow for a lot of additional functionality within OneFS, and then we're going to spend some time talking about what's new for Isilon, which is all very exciting, and then we'll look at OneFS one-on-one. So first, we'll just kind of do a quick overview of Isilon and sort of how we got here. So for 4 years running, Gartner has ranked DellEMC as the industry's #1 solution for scale-out network-attached storage systems. And you know why I kind of bring this slide to the table is it's not just that DellEMC is #1. But I also like to call attention to the margin by which they are #1. They are far and above the competition, particularly some of the folks that, from a competitive standpoint, we normally hear a lot of noise from. And the point here is really that it's not just Dell Technologies that thinks that Isilon is industry leading. It's not just Arrow. It's not just me. Gartner says so too. So it's not a secret that data is growing, and it's also not a secret that more and more of that data is unstructured. It's also not a secret that IT environments of every size are being asked to do more in terms of speed, performance, and reliability, and they're being asked to do it with fewer resources, fewer people, fewer time, fewer dollars. And business problems evolve because this data is growing at very unpredictable clips. This data has to be retained longer. It has to be accessed faster, sometimes even in real time. And traditional RAID-based solutions don't answer the challenges of scaling, speed, data protection, and needs of management for unstructured data. Isilon and now PowerScale as well answers these challenges, and we're going to look at that today. So here are the types of data that the UDS portfolio from Dell Technologies solves problems for. Today, for the sake of time, we're going to be talking about Isilon and PowerScale in the context of file data. But everything we talk about today applies to all three types of unstructured data shown here, and how we manage that is expanding very quickly, particularly since Tuesday. So for the next couple of slides, we're gonna look at Isilon and PowerScale side by side with traditional NAS architecture, which is mostly scale up that is trying to look like scale out. The underlying architecture is scale up with LUNs and volumes that can be difficult to manage and even more difficult to scale. Management complexity arises from the need to set up and manage multiple LUNs and multiple volumes, and RAID as an architecture can be confining in terms of scalability. Traditional NAS solutions, the larger the data environment becomes, the more complex and time-consuming it gets to be to manage those growing numbers of storage silos, and at some point, performance begins to become an issue. On the other hand, OneFS is a single volume, single file system with a single namespace and is extremely simple to manage. Its scale-out architecture I mean, it scales to larger clusters than anybody else in the industry, but it still remains simple to manage no matter how large the data environment becomes. It can be used to consolidate unstructured data storage. It will get rid of costly infrastructure silos and can help prevent data sprawl, create a data lake that your organizations can use to support a wide range of applications and workloads, including data analytics. And we'll take a quick look at the Hadoop integration for Isilon as well. So traditional NAS storage increases capacity by adding shelves, but when you fill up a shelf or the head reaches its limitations, performance starts to drop. And replacing that head is complicated and leads to downtime and disruption. Traditional storage also leads to over-provisioning, and in growing data environments using traditional NAS, the need for multiple volumes often leads to hotspots. So you've got some volumes that are really being consumed, and then you've got other parts of your storage environment that are not being utilized to capacity. And then the result is that this becomes difficult to maintain your performance SLAs, and you're also you also don't have balanced resources. Isilon scale-out architecture makes it very easy to expand capacity and performance. You simply add an additional node as needed to your existing cluster. And with Isilon and PowerScale, each node contains compute, storage, and networking, which means when you add a node, you're adding linear and predictable scalability of both capacity and performance. And in fact, as Isilon clusters get bigger, they get more efficient and they perform even better. So OneFS allows you to dynamically scale capacity and performance easily without disruption by just simply adding nodes. And the auto balance feature automatically rebalances data across all those nodes so that you're not either suffering from hotspots or provisioning. Traditional storage leads to data silos, while Isilon's single volume, single file system has some significant benefits. With traditional storage, the approach is typically to segment or compartmentalize one app to each volume, which leads to inefficiencies. Traditional storage is appliance or volume based, and you also need to set up separate protocol settings per volume so that the right data can be accessed. With traditional NAS, you need to set up separate authentication and security stacks for each volume, and on-premise tiering and cloud integration features are also limited with RAID-based architecture. Isilon, PowerScale, OneFS provides multi-protocol data access, both SMB and NFS, as well as S3 that was announced earlier this week, which we'll talk a little bit about. So you can consolidate unstructured data and support a wide range of applications and workloads all on a single platform. Isilon solutions, again, are very scalable, up to 252 nodes, provide predictable scalability for both capacity and performance. Single authentications and security stack allows for flexible and simple management. And then Isilon provides consistent security and data protection across all the protocols. We're going to talk about data protection a little bit. Security, authentication, permissions, data protection, it all can easily be set up or changed on a per directory basis. And then Isilon offers automated policy-based storage tiering options, including tiering to the cloud, and we'll talk about that as well. So at the heart of Isilon and now PowerScale is the software. The real reason why Isilon can deliver all of this efficiency and scale and lowest cost of ownership in the business is because of the power of Isilon OneFS. The idea behind OneFS is that it can support any data anywhere, and we'll talk about the expanding portfolio, including the introduction of S3 access. And what I hope you see is that regardless of the hardware, the real star of this show is OneFS, and that's what makes Isilon and now subsequently PowerScale different. So because OneFS is a single file system, there's a whole host of management activities that can be automated. Upgrades and additions are evergreen, meaning they don't require reconfiguration and also don't require painful data migrations. Clients mount to any node in the cluster based on a policy, and we'll take a look at that. And all of this can happen because it's not RAID-based. As I mentioned previously, OneFS allows for auto balance, which means that you don't have over-provisioned or underutilized LUNs. This also improves performance because each node is an equally contributing member to performance as well as capacity. Also, auto balance allows Isilon to deliver as much as 80% storage efficiency, meaning significantly less overhead than RAID-based technologies, which means you're actually using more of the capacity that you pay for versus legacy RAID-based architecture. And over the years, DellEMC has conducted study after study to confirm that even for a bare metal server, the cost of acquisition represents a very small part of the total cost of ownership. And certainly this applies to storage in general, but Isilon and PowerScale specifically as well. Auto tiering means that you can align, again, in a policy-based manner, pay for performance-based nodes for workloads that demand flash, and as we'll see later, as of this week, NVMe, and then automatically tier aging data to lower cost media, which means that over the life of the solution, excuse me, your costs will be lower. So the way that this auto tiering happens is through smart pools, which is again part of OneFS, which is a job-based post-process function of OneFS that moves the data where you want it to go and when you want it to move. All this is transparent both to the namespace and to the users while you're making the most of your storage. And then, as I mentioned earlier, Isilon is evergreen, and what this means is that new nodes can be added or removed to the cluster in a non-disruptive manner during production hours. From an organizational standpoint, this means lower costs and no risky migrations. But from a personal standpoint, for storage admins, this means getting your nights and weekends back, which is a quality of life issue and certainly counts for something. So for organizations that are leveraging Hadoop for analytics, OneFS is the first and only scale-out NAS platform to provide native HDFS support. This means you don't have to buy and manage dedicated storage infrastructure for analytics as you would with a direct attached storage approach. This also helps prevent data sprawl, meaning you have multiple copies of data in different parts of your organization. And this also means that you get your business results faster with less human touch, which reduces overhead costs as well. OneFS allows data to be moved to lower cost cloud storage with cloud pools. Cloud pools can connect to DellEMC based private cloud storage, so Isilon as a service, through an open pipe, which does not incur ingress and egress fees. And then from the DellEMC private cloud, data can be archived or leveraged for cloud compute. And by working with a third-party private cloud provider, in this case, Dell Technologies is working with a company called Faction. DellEMC Cloud Storage for Isilon is literally set up next door to the hyperscaler of your choice. And cloud computing can be leveraged with lower latency, and most importantly, by leveraging a private cloud, you're not a prisoner to whichever hyperscaler holds your data, because as we all know, it can be expensive to move your data from one cloud to another. So you're free to use whatever cloud compute service makes sense at the time, and without fear of egress fees. So next, we're going to talk about Gen 6 hardware specifically, and then we'll take a look at the new node additions at the end. Chris, do we have any questions?
Nothing yet in chat.
Okay, cool. So here's a quick overview of Isilon from an architectural standpoint. Isilon is multi-protocol, and users can be authenticated by multiple sources. Not pictured here is the 48-hour-old S3 support. At the application layer, multiple OS are supported. Front-end access can happen at either 10, 25 as of 2 days ago, or 40 gig Ethernet. And then Isilon nodes communicate with each other over a separate high-speed backend for Gen 5, which are still supported over InfiniBand, or 10, 25, or 40 gig Ethernet on the backend. And the most significant design choice and fundamental difference between Isilon and PowerScale and other legacy RAID-based options is that with OneFS, the storage system does not rely on hardware as a critical part of the architecture. Built on, built on FreeBSD's Unix implementation, OneFS combines the 3 layers of traditional storage architectures: file system, volume manager, and data protection into one software layer, so that you have a single intelligent distributed file system. And this, again, sits at the heart of Isilon's ability to overcome challenges that siloed legacy RAID-based solutions struggle with. So a few things to note about Gen 6, and this was important 2 days ago, but it's kind of even more important now to understand some of the coolness about what we launched 2 days ago. But some important things to understand: a minimum cluster for Gen 6 is 4 nodes. This has to do, and there's news to talk about this, which we'll talk about later. This has to do with a number of things, not the least of which is that node pairs share the ability to power each other, in the event of a power supply failure. Also, node pairs mirror each other's journal as writes come in, so in the event of a power failure mid-write, data is still protected. Generally speaking, the power of the hardware lies in the ability to add compute and networking when you add capacity, which is, again, key to the scalability. And then in terms of scaling, the current maximum capacity of a cluster is 252 nodes. But for environments of any size, the ability to grow on demand non-disruptively is a big part of the offering in terms of the hardware architecture and the ability to scale as needed. So in terms of positioning, the first part of the conversation is typically around performance. How fast do you need it? And these are the 2 new nodes over here that we'll talk about in a little bit. And then once the performance issue is kind of addressed, then it's a question of how much of that do you need? One of the values of Isilon's architecture, again, is that you can mix and match node types within a cluster, assuming for Gen 6, a 4-node minimum of each type, to get the capacity and performance that's specific to an environment. So you can mix and match and tier in an automated fashion whatever types of media that your environment requires. Again, because each node is paired, single points of failure are avoided. Once the 4-node minimum is met, additional capacity and performance is met by adding nodes in pairs. And then as data is written, OneFS, by way of Reed-Solomon, in addition to its own algorithms, ensures that data is written only to a single drive in a tray. If a sled is pulled, FEC blocks on other drives can be used to recreate that data, so that a single sled failure will not affect the integrity of your data. And then most of this we've talked about. Again, this is the backside of a Gen 6 chassis. This just gives you a visual representation of the physical layout of how the nodes go into the chassis. So you'll have storage across the front horizontally, and then you'll have your nodes across the back. Chris, we got any questions, or should we move on to data protection?
One of them, I think you already answered it, was around is it common for customers to mix and match nodes? And are you able to pin workloads to particular what nodes for performance?
You can. So we'll talk about that as we get into access zones. But first of all, yes, it is very common, particularly in larger environments, for folks to tier data. And
Right.
in fact, like a perfect example is when we get to Smart Connect and sort of how this all breaks down, I'm zoning stuff out typically by department. So sales, marketing, engineering, and I may want to, if I've got some high performance users that really need the power of Flash, I can dedicate all of their I can dedicate all of the Flash resources to that particular access zone. And then if I've got folks that are more appropriate for spinning drives, and again, because we're going across multiple drives and multiple nodes, you still get extreme performance out of even spinning drives with Flash as metadata cache. You can pin different departments and or workloads to specific media types, and then you can tier those. So even if you have data that's aging, you can in an automated fashion tier it down and then even tier it out to the cloud if that's where your organization thinks that it needs to be. So absolutely. And the only caveat there is that for Gen 6, for an individual node type, it's a 4-node minimum. And then as we look at PowerScale, the new offerings that were introduced a couple of days ago, it's a 3-node minimum. But then once you've got that minimum satisfied for the tier, then you can proceed.
Got it. And one more question was,
Yep.
can I provide my own backend switching, or does Isilon always come with its own?
You can. I will say a number of things about Dell switching that is typically the way that people purchase. Um, if you purchase Dell networking, it will be part of the deployment. This is the backplane of your cluster. And from a deployment perspective, it's important to get it right and to get it right as fast as possible. Time is money. And to make that networking a piece of the deployment is definitely an advantage for customers. Secondly, it will then be part of the support of the entire solution so that you've got a single point of support for the entire solution. And third, what a lot of folks don't understand about Dell networking is that as compared to our competitors, Dell uses merchant silicon to build their switches. So they're buying silicon off of the open market versus a number of our competitors who are having chips burned specifically for their switches. What this means is that Dell Technologies networking compromises nothing for performance and is very competitive on price. So when you consider having it part of the deployment, having it part of the support, and you've got to have it anyway, and it costs less, there's some compelling reasons to go with Dell networking on the back end. But the answer to the question is yes, you can use somebody else's switching. There's just a lot of good reasons not to.
Got it. Okay.
So we're going to chat quickly about data protection. This is somewhat of a deep subject. I could go on it's pretty deep, but we're gonna cover what we can in just a few minutes. On this slide, we're going top to bottom, starting at the left. So key to understanding how OneFS's approach to data protection is different is that OneFS is designed to understand that the more drives and the more nodes we add, the likelihood of having at least one failure increases. And then on top of that, areal density of a disk continues to outpace Moore's law, meaning spinning hard drives are getting bigger faster than they're getting more performant. So in addition to even that still is that the rebuild time of a 6 terabyte SATA drive is limited by the fact that you have a much denser platters served by the same number of heads and actuators. And so all of this significantly raises the probability of a multiple drive failure scenario. And by distributing data across as many drives as possible and as many nodes as possible, this approach understands in advance that failures are going to occur, and it understands in advance how to navigate to maintain performance for when those failures inevitably happen. So moving down, when a client connects to a node, and depending on the policy for that user, it can be any node connecting. The connecting node is going to calculate the data protection scheme based on the policy set for that file, creates the FEC blocks, and a service called Block Allocation Manager determines the right plan for the data. And then moving back up to the top on the right, stripes, including up to 16 8K data blocks and up to 4 8K FEC blocks, are written across as many drives as possible, across as many nodes as possible, as determined by the right plan designed by the block allocation manager on the node that the client connected to. Currently, OneFS is designed to withstand up to 4 simultaneous component failures without a performance hit, and without any dependency on any hardware RAID controllers. So this is just some data protection nomenclature that is specific to Isilon. It's based on plus N data protection that we have seen in scale out solutions. The default protection level is going to be 2 drives and 1 node, which is how you read this. And this is all based on a stripe, which is a collection of data stripe units. So again, up to 16 8K blocks, plus up to 4 FEC stripe units that together become one stripe that is, in most cases, one region of a file, and then all the necessary information to reconstruct that region in the event of a failure. N, so as we're looking at this, so N here, number of data stripe units in a stripe, and then number of FEC stripe units is a maximum of 4, and then M also represents the number of simultaneous failures given a protection scheme that it can tolerate. And then B, so 1 node, is the number of stripe units in a stripe which are allowed to reside on the same node. So if you recall, we talked about it will only stripe to 1 shelf in a node. Sometimes it will be on 2 different shelves in a node, but in this particular case, it's going to only stripe. It's only going to stripe on 1 disk per node. So the stripe width is the number of nodes and drives across which file is striped. So typically, it's going to be the number of stripe units plus the FEC. Requested protection level, this is what I'm actually asking OneFS for my protection level, but actual might be different. So if I give it, and we'll look at this in the next slide, but if I give it a protection level for which I do not have enough nodes, OneFS will figure that out, and it will still give me that protection level typically in the form of mirroring. So I'll get the protection level, I just won't necessarily get the efficiency that I thought I was going to get. And then protection level is synonymous with requested protection level. So here's a list of the data protection schemes. Again, 2 drives, 1 node is the default. As we go down this list, 2 things happen. You need more nodes in order to accommodate it, because I've got to have more nodes to stripe across, as well as I get more efficient as I continue to add more nodes. There's less overhead as I can stripe across more nodes instead of having to maybe put two parts of a stripe on a single node. I get more efficient, and that's definitely speaks to the TCO story for Isilon and PowerScale. So just to kind of review, each protection policy, there's a maximum stripe width and a maximum number of nodes. A minimum number of nodes that are required. Storage efficiency gets better as the cluster gets bigger, and then again the OneFS block size is fixed at 8K, and it cannot be changed. And then that stripe unit is going to be up to 16 blocks of 8K data, and then 4 FEC blocks. And then you're going to have however many parity blocks you have, however many FEC blocks you have, that will determine what your failures to tolerate, or how many failures that you can survive. I'm going to move on to multi-protocol, Chris. How are we doing on questions?
We're good.
Okay. So in order to understand how OneFS deals with multi-protocol access, we have to understand a little bit about Smart Connect, which is a very cool feature of OneFS. Smart Connect enables client, and this also speaks to a little bit of the tiering question and sort of how clients access and data gets pinned to a particular media type. What Smart Connect does is it enables client connections to the storage cluster using a single host name, but this can be more than one host name. So it can be, say, marketing.isilon, sales.isilon, engineering.isilon. So we see typically this is used for departments, and this can all be this access, these individual access zones, as we call them, can be allocated either based on static or dynamically allocated IP addresses. And then within that IP range, Smart Connect Advanced can load balance and distribute client access across the nodes based on intelligent algorithms that are either round robin, connection count, CPU utilization, or aggregate throughput. So the way this works is in our first step, in the blue step, the client makes a DNS request for the Smart Connect zone name, so marketing.isilon.com, by sending a DNS request to the site DNS server. To the site DNS server. That site DNS server has a delegation record for that Smart Connect domain name. So it says, I don't know where marketing.isilon is, but I know a guy. And so it's going to delegate that to the Smart Connect service, which is the Smart Connect service IP address on the Isilon cluster. And basically what Smart Connect is doing here is that it's kind of a mini DNS for the cluster alone. So the cluster node that's hosting the Smart Connect service IP address for that particular zone receives the request, and it's going to calculate the specific IP address of the NIC in the cluster to assign based on the configured connection policy for the pool. So if it's either round robin, connection count, throughput, or CPU utilization, it's going to make that determination on what's the best NIC for it to hit. And then it's going to return that IP address to the DNS server, who will return it to the client, and then the client will connect directly to that IP address. This is a big deal, particularly for like media and entertainment customers are highly sensitive to throughput because there's so much data that's coming and going at the same time. So this ability to load balance internally is a big piece of what Smart Connect does, but it's also how the client gets to the right place on the cluster. So I mentioned access zones. What this does is this enables for the partitioning of the cluster into virtual containers. So again, best example is departments. Access zones can be assigned individual or multiple authentication and identity management services, such as Active Directory or LDAP. And then each user is given an on-disk ID based on either the Active Directory or LDAP authentication, which eventually is compared to the individual file permissions in order to grant or deny access. So as we see here, each GroupNet has a specific DNS and supports multiple subnets. Most environments we see have a single GroupNet, but we do see this like if companies merge and then you have kind of a multi-tenant environment. You may see two completely different GroupNets on the same cluster, which is absolutely supported, and then you're going to have two independent domains as well. Each subnet underneath that GroupNet supports a Smart Connect service IP address, which is what the on-site DNS server is going to connect to. And then it's got multiple IP pools associated with each subnet. Each subnet is associated with an access zone, which is a fully qualified domain name, and that is resolved by Smart Connect. So that's how a client connection gets to an access zone. Once it's there, reading from top to bottom, users come into OneFS. Well, they'll be accessed in that access zone to which they're connected. So for example, marketing. And then that access zone is configured to authenticate, in this case, to either LDAP or Active Directory. And then once that authentication has been determined, the user will receive an on-disk ID, and this token will be used to authorize permissions. And so here's a graphic, that shows how that token is leveraged. Based on the previous slide, the user gets a token and the individual file permissions are authorized based on that on-disk ID. And at the core of the unified permissions model and in the OneFS authentication, identity management, and authorization model, they're all working together as a stack. And when a client connects to the cluster, information is passed all around this stack, which is shown here. All these components work together to complete the user access and determine if access to a particular file is granted. And so here's how a recap of how all that works. When a client connects to an Isilon cluster, that AIMA stack plays a role at each level of the network access hierarchy. So the user connects to a Smart Connect zone name, which is tied to a subnet and an SSIP, which eventually gets it to a Smart Connect zone, and then is mapped to an access zone. And at that access zone level, authentication providers are defined. This is where directory services, user mapping, ID mapping, and ultimately that token is generated. And then for each access zone that's defined, a root-based path is required. The root-based path is where file permissions and the user's identity on disk apply. And this token is what is used to define user's permission to an individual file. So a number of moving parts here. Smart Connect is fundamental to it, but this is also all fundamental to particularly with authenticating either through Active Directory and or LDAP. Smart Connect plays a big piece in this. Okay, so we're gonna talk quickly about software and then we'll get on to what's new. Chris, do we have any questions in the chat?
Nothing on authentication there.
All right, cool. Because it's really confusing and nobody really likes to talk about it anyway.
Yeah, I guess so.
Software is cool, but what's new is cooler, and that's what we're getting to. So we're going to talk about some of the different components of OneFS. Very briefly, Snapshot IQ is exactly what it sounds like, near instantaneous snaps with little to no performance overhead. You can have up to 20,000 snaps per cluster and up to 1,000 per directory. Without the license, you can still view snaps, but you can't control at a granular level what your snap retention looks like. And that's clutch to not having snapshots completely overrun your capacity. So if folks are using snapshots, typically they license Snapshot IQ. Sync IQ, if you have more than one cluster, you can replicate to and from each other, fail over and fail back for disaster recovery. Smart Connect, we talked about it, and it does a number of things, static and dynamic IP allocation. You can create multiple Smart Connect zones, which is really fundamental to multiple access zones or those departments. But with without Smart Connect license, all you get is round robin. When you license it, you get the additional connection count, throughput, and CPU utilizations as load balancing criteria. People ask me all the time, can I use an external load balancer? Sure you can, but it's not going to have visibility to throughput and CPU usage, which is an important criteria for a lot of folks, particularly with a lot of a high number of highly concurrent users. That throughput and CPU usage as a load balancing criteria becomes extremely important. Smart lock, software enforcement of write once, read many in either compliance or governance mode. Smart dedupe is a post-process except on the new stuff that I'll talk about in a minute, and H5600s and the F10s, which is all inline dedupe. But for everything else in the portfolio, Smart dedupe is a post-process job. Smart pools, so this is what helps us with tiering the cluster to different tiers of storage. Smart quotas allows us to assign and manage quotas at the cluster directory or subdirectory user or group levels. Inside IQ is some graphic monitoring and performance and capacity planning, although there's a new tool in our belt as of Tuesday, which we'll talk about, and then Cloud Pools allows you to pool to your favorite hyperscaler. So to kind of summarize before we get into what's new, the big differentiators here are that we've got N+4 data protection, which gives us significantly better tolerance of failures than anybody else in the market. And this is also based on an architectural approach to plan for failure rather than trying to protect it against it. Intelligent load balancing, multi-tenant segregation of access, and all the enterprise software tools in the belt. Before we even talk about what's new, Isilon delivers far and above what our competing RAID-based solutions have to offer. So I will roll right into what's new and just expect, Chris, that you'll jump in if we've got any questions.
That's good.
So let me back up. So we had some significant announcements just 2 days ago. We have new hardware options. We're going to talk about that we're calling PowerScale. We have an update to OneFS, which is now at 9.0. And all of this means some new functionality, new performance that's available, and a new lower point of entry in terms of node count, capacity, and budget. And personally, this is going to open up a whole lot of new unstructured data conversations for customers with Dell Technologies, and we'll take a look at how that all happens. So the cloud story for OneFS continues to evolve. Shown here in the first 2 columns are what I was talking about earlier, which is Isilon as a service, operating in data centers strategically placed next to your favorite hyperscalers. They're low latency, and again, you're not a hostage to any hyperscalers in terms of where your data resides. This middle option, this is a new SKU that allows for a dedicated pipe directly to Azure, which adds some predictability to cost and performance. And then also recently announced GCP supports native OneFS functionality as well. Probably in a lot of cases not the least expensive way to deal with a growing unstructured data set, but it is an option. So based on Clarity Now, which Dell Technologies acquired a couple years ago, Dataiku is designed to control the data lifecycle. With new PowerScale implementations, this is a $0 perpetual license. In a single pane of glass, Dataiku lets me locate data, sometimes in a sea of directories if I've got a large data set. I can determine where it's stored, and I can determine if it's accessible by the right people. Custom automated tagging allows storage admins to logically group data that is possibly from disparate systems and manage it in a more relevant context. And this concept of automated tagging is clutch because it can come through very large data sets and tag them and then group them in a very short amount of time, seconds. So for large data sets, it's a massive time saver. And there's a growing ecosystem of plugins, which is where we're going to find the data mover functionality later this year. So Dataiku is positioned around achieving 3 things. First is the auto discovery of all your unstructured data across heterogeneous platforms. In this example, the folders are file data and the circles are object storage. So this applies to file and object storage. Currently in the Dell Technologies storage portfolio, but very soon to be for third party as well. Understanding the data is number 2. The idea is to identify data type, size, age, when it was modified, so I can see what kind of data do I have and where is it. And then finally, we can organize that data into logical groups according to business context, and I can do this by auto tagging so that we can make decisions about where our data should live. With Dataiku, the idea is that we can make better data decisions and then more precisely move data on demand to the right storage platform, whether that's closer to the workload for better performance, out to the cloud for lower cost, or whatever the criteria is for your organization. So this is just another breakdown of what Dataiku is doing for customers. By giving the ability to rapidly locate data, organize it based on context, and move it as needed, organizations can spend more time figuring out what their data is trying to tell them versus trying to find it. For customers that are monetizing their data, this is huge. Also for M&E customers, this increases the value of the data because it takes them less time and effort to find it, so there's less overhead in it, which makes it, by the time you monetize it and or deliver the content, it makes it more valuable because it costs you less money to get it there. So so Dataiku has been much anticipated. I've been playing with it. The auto tagging thing is super cool, and I'm pretty excited about this new option. CloudIQ is a no-cost cloud-native application that leverages machine learning to monitor and measure the overall health of storage systems through predictive analytics, oftentimes compared to sort of a health app for your storage. Previously, it's only been available for other solutions in the DellEMC portfolio. This announcement was made earlier this year, but it's still an important one. And the idea is that through a proactive health score, you can sort of at a glance see what's going on with your environment. Through the predictive analytics, it uses 2 years of tracking history to give you some predictive capacity planning insight. And this is huge, whether you're a big organization, small, or somewhere in the middle. Capacity planning, particularly as it relates to unstructured data, is a challenge for most everyone I talk to. And then anomaly detection, I can figure out what my problems are before I have them. Kubernetes adoption continues to grow, and accordingly, we now have now Isilon can support the platform with the container storage interface. This also was an announcement that was made a little bit earlier this year. This is basically an API that presents NAS shares as scalable, persistent storage to multiple pods, while leveraging all of the Isilon and PowerScale goodness on the back end that we've already talked about. Current support is for Kubernetes on Red Hat Enterprise Linux, but expect to see more like OpenShift, and there's others on the roadmap. I mentioned this earlier. The introduction of S3 support enables customers to run applications that rely on object storage. So whether it's mobile or cloud, the app will see the protocol just like SMB or NFS. And PowerScale implements the S3 API as a first-class protocol on top of the file system, right alongside NFS, SMB, HDFS, and all the other protocols it supports. So an example is if you have an existing data set on Isilon, you can upgrade it to 9.0. And now you can use S3 protocol to provide developers an easy way to access the assets on the Isilon cluster, so be them NFS files or SMB or whatever. And they can do that without having to interact with the storage admin, so it's streamlining that process. And then as a point of clarification, we're accessing file data, again, by the way of the S3 protocol. OneFS implements the protocol on top of the file system engine, just like all the rest of the protocols that it supports. Clients that connect to a OneFS cluster with S3 are getting access to OneFS and all of its goodness and performance. And clients are going to connect to S3 by either HTTP or HTTPS, and then use standard REST calls such as put, get, and post to perform bucket and object operations. So if you peel the onion back, basically this is an API that associates a bucket with a file and or directory, and vice versa. But this is gonna open up a whole new possibility for new probably cloud-based, but a number of different application development opportunities that rely on S3 as a protocol. We announced this earlier this year, but it's a big deal. OneFS now supports 16 terabyte file sizes. This speaks directly to workloads like drone telemetry, automated driver assist, oil and gas, EDA, and of course the media and entertainment guys love this because their files are huge. And here is the main attraction. The idea is that the #1 scale-out NAS and the #1 server technology are coming together. And now we have a solution that is extremely performant. It's a smaller capacity node and comes with a smaller node requirement. This is going to change the conversation around unstructured data moving forward. PowerScale requires a 3-node minimum, not a 4-node minimum like Gen 6. So this allows for smaller configs and subsequently smaller budgetary requirements. The F200 offers an all-flash option with up to 16 terabytes of physical capacity per node. For customers that have previously not been able to consider Isilon because of the minimum requirements, PowerScale offers an extremely viable option. The F600 with all NVMe drives, again with a 3-node minimum per tier, offers performance at a price that makes sense. And NVMe is not, we haven't been playing in that space before, so this is also very exciting. So the F200 is a single socket box with up to 96 gig of memory. Both front end and back end connectivity is Ethernet. So a tier of F200s can commingle with Gen 6 nodes that we previously talked about. Deduplication is in line to ensure efficient use of the media, whether we're talking about customers that are new to Isilon, or if we're talking about existing Isilon customers looking for a cost-effective performance tier. The F200 offers a very cool new option. Then the F600 is a 2-socket box with up to 192 gig of memory, offers several different sizes of NVMe drives. This kind of speed is new to Isilon, and at a node count, capacity per node, and financial ask, that makes sense. Newer or existing Isilon customers have an option that is very compelling in terms of performance and price. So some ideas on use cases, edge cases, for sure, but this is changing the conversation and bringing smaller customers into the mix to open up more opportunities. So we're very excited about what these new opportunities look like. And so here's a new family photo. Whether we're talking about performance, mixed workloads, or the cloud, because of auto tiering, PowerScale can be built to fit customers' requirements for unstructured data, as well as capacity and budgetary requirements in a way that has not previously been possible before this announcement. So we're looking forward to having lots of new conversations with folks around the new offerings as they start to solve their unstructured data problems. Chris, as I transition into the demo, what kind of questions do we have?
Nothing specifically from chat, but just from my side, I think you stressed this a few times, the introduction of the smaller units, a lower cost of entry into this space, I think is going to be huge. Previously, customers I'd spoken to have been put off by Isilon just because it was a higher cost of entry and a high amount of terabytes minimum. So I think a combination of the lower point of entry as well as introduction of S3 support, I think is huge.
Yep.
One thing I'd like to get my hands on is just understanding to what extent S3 API is supported. What functions are supported, because that's a continuously evolving API, and I'm sure Dell keeps a checklist somewhere of where that stands. So it'd be interesting to get hold of that.
Yeah, and it's deep. There's a lot to it. I've had 48 whole hours to get my head around this. I mean, I was able to participate in some NDA stuff prior to, but excuse me, in terms of really getting my hands on it, I've had about 48 hours, and there is a lot there. And I expect that the S3 protocol support will continue to grow. But in combination with Data IQ and the node count and the node requirements is big. And I mean, the analogy that I like to use is that previously with Gen 6, we were asking unstructured data customers to kind of cannonball into the deep end of Isilon. Now they have the opportunity to sort of gently walk down the steps in the shallow end, figure out the solution and what it can do for them, and then let the solution continue to grow as their business grows.
Well, great analogy. I've always been a cannonball person myself.
One of the things I love about you, sir. All right, so we're going to look in the very few remaining minutes that we have. I wanted to take a quick look at OneFS. In all transparency, I was very much hoping to show you guys 9.0. I'm in a virtualized environment so that I can show you guys adding and taking nodes out, which I don't have the luxury of doing in my own lab. The virtualized environment that I have access to with 9.0 was not exactly behaving the way that I wanted it to this morning. Not a function of the operating system, it was a function of the virtual environment. So we are going with a little bit more predictable result here so that I can show you guys a few things. But as you can see, I've got a menu across the top here, and I'm very abbreviated on time, so I'm probably gonna fly through some of this. But what I wanted to show you from an expansion standpoint is to show you how easy it is to add and fail a node. So when I go into hardware configuration, again, it's going to auto discover anything that's already connected to the network. And I'm going to tell OneFS that I want to add a node. It's going to say which one. I'm going to tell it, and then I'm going to add a node. And then when I go back to my cluster overview, I can see this new node coming on. So it's red now as I continue to refresh. If there was data in this environment, again, this is a demo environment, so there's not a whole lot of data to be moved around. This would take a while, right? Because I've got to move some data. That auto balance is gonna kick in when I bring this node online. Now it's showing me here that I'm up and ready to go. So then if I need to bring that node down for maintenance, I can do that just as easily. I'm again in a little bit of a time warp because I don't have data on any of these nodes. But then if I want to smart fail it, I just tell it so. I'm going to smart fail it, and then it's going to move the data off of that node to other nodes in the cluster. And I'm going to see it right here as in smart fail mode, meaning it's on its way to being completely shut down. So super easy to add and remove nodes. I will show you very quickly a little bit about doing some SMB shares. So I just kind of want to show you guys here in this. So IFS is the default share. Typically, I wouldn't be doing anything in this, but for this environment, I am. But just wanted to show you, I've got already set up a test file. I've got this test text file here, and then once I have that created, I can go over here to my SSH connection, and I can see it. So if I go, this is just a little bit about, so OneFS is Unix based. So for Unix command line folks, they're going to be very comfortable here. So I can go there and then see that I've got my file here created. And then if I want to create a new share, I can either do that from my GUI, or I can do it from the command line. I'm going to do it here for the sake of time. I'm just going to go to Windows Sharing, and then I'm going to create an SMB share. Name. Path. Go down here, and I'm going to edit this real quick. Give everybody full control. And then create share. And it's just as easy on the NFS side. And so then I can see that it's created. Ran a little long on my content. I want to be respectful of everyone's time. There's definitely more of this demo that we could go into. There's also some hands-on labs that we can share. I'm really just kind of wanted to show you guys this sort of from a 20,000 foot overview. A lot more to understand about OneFS and its functionality. And I think Chris, Brian may have something to add to that. Brian, did you want to jump in?
Yeah, no, thank you so much, Todd, for reviewing that and giving that short demo. If anybody on the call would like more of a more of a deep dive into this solution, we are offering a hands-on lab in conjunction with Todd. So I will be sending out a survey link right now within the chat. So please fill that out and let us know that of your interest. And we also will be following up to each attendee, just giving them that option for a hands-on lab in conjunction with Todd. Chris, anything else on your end before we finalize?
Nothing else from my end. I think it was an excellent overview. Once again, I'm super excited about the huge announcements from Isilon. I think it's their biggest one in years in terms of announcements. So this should be a very interesting space over the next 12 months.
Yeah, and I look forward to connecting with as many people as possible. Individually, Chris and I can work together to make sure that you guys see and understand what you need to know about the new offering, as well as OneFS as a file system, so that we can get you guys where you need to be for solving some of your problems with unstructured data. So thanks for your time.